Okay, so again, hello all, welcome. So today we will be solving another graph and DFS problem. It's basically the third problem in as part of the graph theory plan that you see here. Okay, so this problem is 695 max area island that we need to find. Okay, it has been asked in Amazon, Bloomberg, and Dropbox. I think some other as well. Yeah, Google, Expedia, D Show, and all those. Okay. Recently, it has been asked in these companies. Previously, I think. Okay, got it. So let's try to understand the problem first, and with our usual approach. Okay, first we try to understand the problem, then try to come up with a solution, and then write the actual code. Okay. So first of all, I read the problem. So it says you're given a m cross n binary matrix, again a grid. An island is a group of ones, again like previous problems that we've seen. So ones are representing land here, and zeros are representing water, as evident by the color as well. So an island is a group of ones that are four directionally connected to each other. Okay, horizontal or vertical. You may assume all four edges of the grid are surrounded by water. So in this case, what it says is even this is an island. This is an island because the edges are also surrounded by water. So area of island is a number of cells with value 1 in the island. So the area is nothing but just the count of ones in each of the islands. So in this case, the area is 5, area 4, area 1, area 4, area 5, area 6. So we have to return the maximum area of island possible in the grid. If there is no island, then return 0. Okay. So in this case, the maximum area island is 6. So that's what the answer is. If there are all zeros, then obviously return 0. That's a trivial case that they won't. So m and n can take a values up to 50. Okay. It's like previous problems only. And it's also seems similar to the previous problem that we have done. So like we'll just try to write a DFS solution for this as well. Okay. Let's go to the whiteboard and I'll try to write a solution for this one. I won't draw the whole grid, but it will take a lot of time. But just to give you an information, like I'll just draw from maybe here to here. Okay, let's take that example. Zero one zero one zero zero. I think this should be enough to help us understand and proceed. So we are surrounded by water on all four sides. This is also water. This is also water. So, see, since this is diagonally connected, it will not classify as like this whole island won't be possible, okay? So island is only this portion because these are four directionally connected to each other. Similarly, this one is also an island, okay? So this is the max area island in this case. So if you have not seen flood fill or number of islands video, it is a good idea to check that out because we'll be using the same approach from those kind of problems. Okay, but nevertheless, I'll just start from the beginning itself. So the first approach is, so in any case, to find an island, whether it is one or zero, we need to basically iterate over the grid. Okay, there is no other way to find this island. So we will start with iterate over whole grid starting from 0 comma 0. Okay, if a cell contains, if it is 0, I think we can skip it because it's not helpful in calculating the area of island. Skip it. Or if a cell has already been visited. So this kind of scenario can happen because, for example, if we come to this cell, okay, when you perform DFS for this one, it will, for the second one I'm talking about in the first row. So when you perform DFS on this, so it will visit these ones as well. So when we start iterating from this from 0 0, when we come to this, it has already been visited. There's no point to calculate the island containing this one because this island has previously been calculated already. So that's why even in this case we skip it. Okay. Else perform DFS on the cell. You will find an island. Just maintain a counter count of ones in the island. Compare the count of ones in every island with our max area variable. Okay, so this is the kind of approach that we will try. Okay, hopefully that should be okay. What we are trying to do is, it's kind of similar to previous problems, just we need to maintain a counter variable where for every island that we visit, we'll keep a track of how many ones that we have seen in this island. Okay, so I'll come to that code for now, but let's see how this is. Okay, so when we visit this one, we'll visit this one. So we'll come up with this island. Okay, so for every island, we'll maintain a counter. For this one, it will say and maintain max area variable. So what we will do is we will just apply math.max, compare the previous variable value with the present count. That's how we will calculate actually. This is the final answer for us. Let's try to write a code for this, okay? Uh, I'll keep it like this so that it's still visible. Let's see what the functional signatures that we have provided, okay? So we have provided, sorry, public int. We are just provided an integer grid. Okay. Again, we have to somehow keep track of visited elements. So since the grid can contain only zeros and ones, again, it's a good idea to keep changing the value of whatever element it we visited. Uh, Even if, for example, if it is one, then we mark it as, if it is visited, okay, we mark it as two, okay, because there are only zeros and ones, so it is easy to identify. Okay, if certain cell is two, that we know that we have visited it. There's no longer need to calculate the area containing that cell, or basically process or perform DFS on that cell. It's not needed at all. It's a kind of as useless to us as zero in this case. Okay, we are only interested in ones and the islands. So let's go about it. Okay, first thing again, we'll start with storing the m and n values, which will be helpful. This step is optional. I'm just from the readability point of view, I'm doing this. Uh, Ignore the semicolon. N is equal to, okay, yeah. Now we need one variable to store the max area. Okay, what else is needed? Boolean visited array. You can keep track of visited element by Boolean array as well, or you can modify that value itself. Okay. So for understanding purpose, I will use the Boolean array here, just so that everyone is clear to it, because it's very easy to understand via Boolean array. So what Boolean array means is, for every cell, we will just keep a track of storing true and false value for whether that cell has been visited or not. So let's start with this approach only, like previous. Okay, we will do the optimization on this later. New. Okay, now we have to iterate over the grid. So for iteration, I have to write two for loops, one for row, one for column. Now, again, if statement will come, because we only want to do DFS or perform or calculate an island only when that particular cell of where we are at is a land. Okay, if it is water, we don't waste our time with that. Okay, or if it has been visited, we don't waste our time either. So if I or j has been visited, so what this negation means is, as a whole, we will go into if only when that particular cell has not been visited. And this is an and condition, okay? Um, it should not have been visited and it should not be zero. Just a minute. It should not be zero as well. What is happening? Okay. Then we will perform DFS. Perform DFS, provide grid I, j. visited. And again, like we need to keep track of the number of ones. Okay, so what I used to do is, you can do it any other way. I maintain, I initialize account variable. I initialize account variable like this, new int 1. So basically an array of size 1 which will store my count. And why I'm using array? Because I want to pass this value by reference. So what this means is, whenever we perform recursion and provide this count value will not change, okay, in every recursive call. Uh, that's what my understanding is, because if you provide the integer this variable like this, like without an array, arrays are always passed by reference in Java. If you provide it like that, it will create a separate variable in each recursive call. That's what my understanding is, and it doesn't seem to work. But you can do the experiment uh, on your own regarding this. So basically, we this is an important step. Count of ones it will be storing for every island. Now we could have initialized this inside the if statement also. Basically, for each island that we'll find, we'll initialize this count. But the issue is, it will end up creating so many variables, okay? Wherever so if there are, let's say, 100 islands in the grid possible, uh, so it will initialize the count for each every time it finds an island, okay? So it will be creating that count variable again and again. So it's a good idea to basically just initialize it once and just use that variable. So whenever we have found the number of ones in a certain island, we will just restore the count value to 0. So provide this count, okay? And after this, we will get some count value. We just need to compare math.max, compare it against the existing max area value, which will store the maximum area island. Okay, maximum area of an island possible. Okay, so compare this count value against that. Okay, then we can just maybe restore the value and close these for loops. And at the end, we just need to return max area. That will be the end of it. Again, we need to just implement this DFS. Okay, DFS will be provided with grid, row value, column value, and visited array, as well as count. Okay, now if again the usual conditions, if it is out of bounds, we will directly return it. Okay. Also, if it has been visited or if its value is 0, return because it's water or it has already been visited. No use of calculating or performing DFS on that. Now we do the actual step where we are at certain one within the grid while finding the island. So we will just mark it as visited as true for that particular cell, and we will also increment the counter because this is a genuine one that we need to include in our count. Okay, so this will be count 0 plus plus, and then perform 4 directional DFS on all its neighbors r plus 1 comma c visited count. Do this 4 times, but change the values of r and c accordingly. Similarly, r c minus 1, r c plus 1. And yeah, that's the end of it. Uh, this I should correct. It should be a semicolon here. So basically, 4 recursive calls on 4 adjacent neighbors of r comma c. Okay, now we'll try to write the code for this. So we have already written the code, but I actually in the editor will try to write it. You can use this as reference. So we will do exactly that. Okay. Mm. First of all, m is the number of rows, n is the number of columns, and the max area variable. Okay. This is a visited array. One count variable as well. So just to ensure that this value doesn't change, that's how like I like to use this. I initialize a array of size 1 because arrays are passed by reference in Java. So I am sure this count value, whenever I call it in recursive calls, further recursive calls while doing DFS, this won't change. You can do it any other way if you want, okay? But this is how I do it. So for int I equal to 0, I less than m, I plus plus. So we will go only into if when it has not been visited and its value is not 0. Only then we will do DFS or try to find island for that. Okay. Now we write the actual codes. Okay. So if condition is there, now we can use DFS provide the grade I, j value, and visit it and counts max area needs to be updated. So after performing this DFS, this function will ultimately come up with a count of number of ones present in the island starting at 1, comma 1, comma j, or island consisting of 1, comma j. It will come up with a count. Let's say 4 or 5. Okay. Now we need to compare that count against the max area variable, because if it is greater than max area, then max area for sure needs to be updated. Uh, if it is less, then it won't be updated. So it's like that, okay? And then restore the count to 0, so that when this count goes again for certain other island, it is starting from 0. So that's why we are doing this. Okay. At the end, just return. It should be small max area. Yeah, I should update this. Okay, we just need to write the DFS code here. These are boundary conditions. So I think you can do this count thing by maintaining global variable as well. That should also work, I think. But this is how I do it, okay? This is more clear to me actually. So, okay. If it has been visited, or if grid RC is equal to 0, which is water, return. Don't need to do further calculation or visit further neighbors of these particular cells which are matching this condition. If not, if it is indeed a 1, we mark it as true, okay, and we initialize the count. We basically increment the count, sorry, because it's a genuine one that we need to consider. So, for example, we start performing DFS on this, so this count will be becoming 1, then it will come to this neighbor, it will become 2, and so on. Ultimately, this 4 count will be returned here. So, yeah, just perform DFS on 4 neighbors of RNC. Just change this value to -c. Looks okay. Let's try running it. Mm, some issues. Let's see what issues come up. Okay, it's accepted actually. Let's submit it. So see, runtime is not actually, it's okay, okay. So it's 67.65% beating, 3 milliseconds. That's fine. Memory also it's showing. So these are not actually, one shouldn't look into this a lot, but just try to analyze just by looking at the code. What we can see is we are actually using additional memory for visited. Okay. Other than that, the time complexity here, what we can see is at max we will be visiting all the nodes like previous. Okay. At max we will visit all of them. So time complexity, I can write it here itself. Big O of mn. Now space complexity for this code, as you will find, it's also big of mn because whatever size grid that we are provided with, we are creating a visited Boolean array for that. So as I discussed in the previous videos, we can bypass this thing by actually modifying the value of the cells itself to mark them as visited or not. So in this case, I will be using, so since grid only contains 0 and 1, I will be using a value of 2 to mark a cell as visited or not. Okay, so I can just change my code a little bit. So it will be called grid RC should be okay. Let's get rid of this thing. I think there is shortcut to do this simultaneously, but I'll look into it later. Um, okay, you can get rid of this. Here, it should not be 2. Basically, uh, I'll write a comment here. Yeah, looks good to me. Let's try to run it. And this space complexity now becomes O of 1. Because count also we are initializing it once and just using and updating the value accordingly. Uh, no other variable has been used which varies with the size of the grid. So space complexity has become O of 1. Now let's submit it. See, the time complexity has improved, but don't trust these numbers. So even earlier it was showing memory used as 42.2. Even now it is showing that. So don't trust these numbers are is not reliable as such, but basically will give you some idea, a rough idea of how the code is doing. So we know for sure now that space complexity of 1. Okay. So that's all I wanted to share with this video. Hopefully it was helpful for you guys. Let's meet and solve another problem. Okay, after this. Okay, bye.